Assalamualaikum and good day to everyone. We are from Group E and today we are going to present about thermal properties measurements of ceramic and polymer samples. So today, I would like to introduce the characterizations of ceramic and polymer materials, which are widely used in advanced technologies due to their unique mechanical, thermal and optical properties. Ceramics are known for their exceptional hardness and thermal stability, making them ideal for high temperature and wear resistance application. On the other hand, polymers offer lightweight flexibility and can be engineered to a specific optical properties, which is useful in areas like electronics and photonics. To determine how suitable these materials are for different applications, we apply a comprehensive analysis using three key techniques. First, the Vickers hardness test is used to measure mechanical strength by pressing a diamond indenter into the surface. Smaller indentation indicate a harder material. Next, we use thermogravimetric analysis or TGA, which monitors mass changes as material is heated. This helps us to understand thermal stability and decomposition behavior. Lastly, we perform UV visual spectroscopy to study how the material absorbs light in the ultraviolet and visible range. This reveals important information about electronic transition and helps to determine the optical band gap. By combining these methods, we gain a detailed understanding of how ceramic and polymers material behave under a different condition, which is allowing us to make informed decisions for design, selection, and application development in modern science and engineering. The objectives for these experiments are to determine the hardness of ceramic and polymer materials, to measure thermal parameters, endotherms and exotherms, and mass loss, and also to determine the optical band gap from refractive index using Lorentz formula.
Hi, I'm NURKHAIRINA DALILA and now I will explain to you about the literature review. First, why study ceramics and polymers? Ceramics, like those in your coffee mug, are hard, brittle and withstand extreme heat. Next, polymers, like plastic bottles, are lightweight and flexible, ideal for packaging or insulation. To compare them, we use three tests. First is the Vickers hardness, where we press the diamond into materials to measure the resistance. The second one is TGA, where heating samples to see when they degrade. And the third one is UV spectroscopy, where we shine light to check if there are insulators or semiconductors. So first, how do we measure hardness? We will use a Falcon 459 tester to press a diamond into samples, which is eggshells, ceramic mugs, plastic bottles, and erbium glass. After 10 seconds, we measure the tiny indents under the microscope, and smaller dents mean harder materials. So next, we will test the thermal stability in a TGA machine. We will heat the plastics, foam, and also ceramics up to 800 Celsius while tracking the mass loss. We will record the mass loss versus the temperature. And finally, we will analyze light absorption with UV spectroscopy. We will make thin films of each material and shine UV to the visible light, which is 200 to 1000 nanometer through them.
Hi, I am NURKHAIRINA and I will talk about calculation part. Part 1. The objective is to determine the hardness of ceramic and polymer materials. In this section, I will explain how we calculate the Vickers hardness of eggshell materials using a data from a micro hardness tester. The Vickers hardness test applies a fixed load, in our case 0.3 kg force using a diamond-shaped indenter. The hardness value is calculated based on the diagonal length of the indentation left on the surface. The formula used is HV equal to 1.854 times load over D squared, where D is the average of two diagonal measurements, which is D1 and D2 in millimeters. That takes one of the indentation for the eggshells is D1 equal to 0.1641 mm and D2 is 0.2132 mm. So We substitute all of this into formula. We repeat this calculation for 2 more indentation and obtain the hardness value of the average of the sample. From what we calculate, the sample of eggshell, the average is 78.58. The ceramic mark is 617.64. The Arabian glass is 698.78. So this is a graph for eggshell, plastic bottle, ceramic mug and glass for hardness figures. For calculation part 2, to measure thermal parameters endotherm and exotherm and mass loss, we use mass loss percentage formula, which is find the mass minus initial mass over initial mass times 100%. Based on my data, plastic bottle, the mass loss is 91.53, the foam is 100%, eggshell is 43.45%, Arabian glass is 3.26%, and the ceramic mug is 1.16%. For endotherm, the major is plastic bottle and foam. For exotherm, possible minor is for plastic bottle and also foam. For eggshell and Arabian glass and ceramic mug, the exotherm is none of that. For calculation in part 3 is to determine the optical band gap using UV-Vis and Lorentz formula. In this section, I will explain how we estimate the optical band gap material using UV visible spectroscopy. We recorded the absorption of foam over a wavelength from range 200 to 1000 nanometers. From the graph, we identified the absorption age where the material start absorbing significantly. So this was the example of the graph. From the sample, foam, the lambda max in nanometer is 270 and the lambda H is 240. The band gap is 5.17. It behaves as insulator. For eggshell, the lambda max is 284, the lambda H is 240. The band gap is 5.17 also, and it behaves also as insulator. For plastic bottle, the lambda max is 320, lambda H is 300, the band gap is 4.13, and it also behaves as insulator. For Arabian glass, the lambda max is 256, lambda H is 230, the band gap is 5.39. It behaves as UV transparent glass. And lastly is ceramic mug. The lambda max is 984, the lambda H is 680, the band gap is 1.82. It behaves as semiconductor.
Now we move on to discussion. Part A, the hardness test. First, we will go through the ceramic samples. Firstly, the eggshell. We have calculated the HV of 78.58. Next, for the average HV for ceramic mug is 617.64, and the erbium glass have average HV of 698.78. The highest average HV calculated is the erbium glass. For the polymer sample, the plastic bottle has the average HV of 13.40, while the foam shows no reading as no indentation was done on its surface nor can be observed. Next, part B, endotherm, exotherm, and mass loss, aka the thermal properties for the samples. We are setting a maximum temperature of 1000 degrees Celsius to fit for all samples boiling point. Firstly, we will going through the polymer samples. The plastic bottle has a mass loss of 91.53%, and it shows major endotherm events between 300 degrees Celsius and 500 degrees Celsius, and also possibly minor exotherm events. Next, to the next polymer sample, the foam is having 100% mass loss in the machine as it has a major endotherm event between 250 degrees Celsius and 450 degrees Celsius with a minor exotherm event. Now we move on to the ceramic samples. The eggshell has a mass loss of 43.45% with multiple endotherm events as it has a minor endotherm
event approximately around 100 degrees Celsius and major endotherm event between 700 degrees Celsius and 800 degrees Celsius, as decomposition of CaCO3 is happening around this temperature. This eggshell, however, shows no exotherm events at all. The erbium glass has a mass loss of 3.26% with a minor endotherm event, as moisture is lost approximately 100 degrees Celsius with no exotherm event. Lastly, the ceramic mug shows the lowest mass loss at 1.16% with minor endotherm event at approximately 100 degrees Celsius for moisture and no exotherm events too. Lastly, part C, the band gap. From the result, foam has a band gap of 5.17 eV and plastic bottle has band gap of 4.13 eV. For both of these polymer samples, they show a big band gap, indicating that they have an insulating property. As for the ceramic samples, we found out that erbium glass, ceramic mug, and eggshell have band gaps of 5.39, 1.82, and 5.17 eV respectively. This shows the different properties for each of the ceramic samples, even though they fall under the same material group. The eggshell, naturally formed ceramic from CaCO3, is proven to be a great insulator as it has a big band gap. The erbium glass is also an excellent insulator. The peak in the graph is showing the wavelength of its color, as erbium glass is physically pink in color, therefore peak around 508 nanometer and 536 nanometer was observed. As for ceramic mug, the small band gap possibly indicates semiconducting property with a possible of NIR absorption. Now we are moving from discussion to the conclusion part. The plastic bottle has a band gap of 4.13 eV, indicating its insulating properties, and experiencing a mass loss of 91.53% with having both endotherm event and exotherm event going. Its hardness is calculated to be 13.40. The foam has no observation in the hardness test due to its porous and soft physical. The foam is observed to lose its mass 100% with both endotherm and exotherm event present. It also has band gap of 5.17 eV, indicating it is an insulator due to its big band gap. The eggshell has a band gap of 5.17 eV, showing that it's great naturally occurring insulator. The average HV from hardness test is 78.58 and is experiencing 43.45% mass loss with only endotherm events present. The ceramic mug has a band gap of 1.82 eV, indicating its semiconductor properties, and it has the average HV of 617.64. It experiences the lowest mass loss of 1.16% with only endotherm events happen. And lastly, the erbium glass is experiencing a mass loss of 3.26% and it has a hardness of 698.78. The glass only has mass loss of 3.26% with only endotherm events happen. The objective of this experiment is achieved.
That is all from our group. Thank you so much.